Convolutional neural networks (CNN) are widely used in pattern and image recognition as they have a number of advantages as compared to another techniques. CNNs or a convolutional neural network is a special case of neural network consists of one or more convolutional layers, one or more subsampling layers, and a ReLU, and one or more fully connected layer as in the standard neural network. Always convolutional layers will be followed by a subsampling layer. Okay, this is the typical block diagram of convolution layer consists of inputs, and in first stage there are convolutions, and after convolution subsampling, and we use ReLU if we need it. Okay, and in second stage again there is a convolutional layers, a subsampling layer, and again convolutions. We do convolutions many times as much as we need it, and at the end the last layer is classifier, which consists of fully connected layers. Okay, so what is convolution layer? NCNN convolution layer play the important role of feature extractor, but they are not handy guys. Convolution layer is used to extract the local features such as edges, lines, etc. The weight of these convolutional layers being used for feature extraction as well as the fully connected layer being used for classification are determined during the training process. Okay, so weight will be assigned and will be changed in the process of training. This is the convolution. So what is convolution? Again, we see that convolutional layer extract low feature like edges, lines, corners. High level features, high level convolution layer will be used to extract the high level features. Okay, so here is in convolution what we do, we have a kernel and we have the input image, so we convolve the kernel with the input image. So here we have the kernel with 1 1 1 1, and this is the image. So we convolve the kernel with the first four numbers of the image. Okay, so simply multiply it 1 time 1, 1 time 2, 1 time 4, 1 time 5, and we simply add them, which is equal to 12. So here we see in the output 12. Again we convolve this matrix with these four numbers. Okay, so 1 time 2 multiply by 1 time 3 multiply by 1 time 5 multiply by 1 time 6. Okay, so let's see. uh, we take this box. 1 time 4 multiply by equal to 4, 1 time 5 equal to 5, 1 time 7 equal to 7, and 1 time 8 equal to 8. Adding them is equal to 24, so here 24. Okay, the next layer is pooling or subsampling layer, and the pooling layer or the subsampling layer, what we do, we divide the input features into regions. Each region have size of 2 cross 2. Okay, the pooling layer is used to reduce the resolution of the feature. It makes the feature robust against noise and distortion. Okay, so we have two types of pooling. First is max pooling and second is average pooling. Okay, in both cases the input is divided into non-overlapping two-dimensional spaces, so these regions will be the size of this region will be 2 cross 2. So what we do in the average pooling, we find the average of these 2 cross 2, which is 4 values, and in the max pooling we calculate the maximum, we select the maximum value of these 4 values. Okay, so here is the average pooling. What we do in the first four numbers 21, 8, 12, 19, here if we find its average 21 plus 8 equal to 29, 29, 29 plus 12 equal to 41, 41 plus 19 equal to 60. 60 divided by numbers 4 equal to 15. And in max pooling what we do, we simply find the maximum value of these four, which is 21. So here 21, and the next we see that 12 is the maximum value. Okay, 12. Okay, and then the next layer is ReLU. What is ReLU? ReLU simply implement the function y equal to max of x comma 0. what we do in the ReLU, simply we discard the negative values and make it 0. Okay, what is this? It simply increase the nonlinear property of the decision function and the overall network without affecting the receptive field of convolution layer. Okay, we have different nonlinear function, which is also hyperbolic, tangent, absolute of hyperbolic tangent, and sigmoid. And what is the advantage of ReLU? Why we are using ReLU? Simply it makes the network faster. Okay, so here is the ReLU. Simply what we do, we, if the value is positive, it will be maintained, but if the value is negative, we will change it to 0. Okay, let's suppose this is minus 1 110, here it is 0, minus 10 0, 25, it will be 25, should be 25, we doesn't change 25. Okay, minus 15, so it is 0. And at the end we have fully connected layer, and fully connected layer are often used as the final layer of a CNN. This layer mathematically sum weighting of the previous layer of features. All these element, all the element of all features of the previous layer get used in calculation of each element with each of the output feature. Okay, this is the fully connected layer, and which what we do, we fully connect the previous layers with some weight to the output. Okay, then why CNN? Why we are using CNN? Here are some advantages of CNN. While neural network and other pattern detection method have around of uh, the past 50 years, there have been significant development in the area of convolution neural network in recent past. What we do in CNN simply we use the same coefficient across the different location. That's why the memory requirements is much smaller as compared to the traditional neural network. And when the memory as requirement is smaller or reduced, simply training time will be reduced. Okay, and also CNN is rushed to distortion such as change in shape, camera lens, lighting conditions, different poses, presence of partial occlusion, horizontal and vertical shaped, etc. Okay, that's all.